All right, good morning, everybody. It is 8:40 on Friday, so let's go ahead and get started with Unit 6, Lesson 10, using data displays to find associations. So for a survey, students were asked, do you play a sport or do you play a musical instrument? This two-way table gives some results from the survey. Complete the table assuming that all students answered both questions. So if we take a look at this, let me change this purple because purple's God. If students were asked if they played a sport, right? A total of 16 students were asked. 5 of them play a sport, so how many don't? Sorry. If 5 students play sports and instruments, how many play sports but don't play instruments? 11, right? Because 5 plus 11 is 16. Similarly, if out of those who do not play instruments, if 11 of those play a sport, how many don't play a sport? 4. Now, if we look at this row right here, we know there's a total of 25 students. This one has 15, so what should go here? 10. And if 10 total people play instruments and 5 of them play a sport, how many don't play a sport? 5. And what's 5 plus 4? 9. It's like a little puzzle. So to the nearest percentage point, what percentage of students who play a sport don't play an instrument? What percentage of students who play a sport? So how many students play a sport? 16, right? And how many don't play a musical instrument out of those who play a sport? 11. So what's 11 divided by 16? Let me use my calculator. I'm going to say it's above 50%. Yep, 68.75%. And to the nearest percentage point, what percentage of students who don't play a sport? So let's look at how many don't play a sport. That's this right here. There's 9 people that don't play a sport. So that's the whole. Also don't play a musical instrument. So how many don't play an instrument? 4. This one's easy to calculate if you know what 4 ninths is. That's 44.4%. Ooh, your teacher will give you a 2-way oof. Oof. Well, in that case, yeah, I wonder if I can actually upload the documents so that you guys can use them. But then it would be kind of difficult because it's like you get the whole thing. Can't do this, bruh. I can't do this. All right, there we go. So, an eraser factory has 5 machines. One machine makes the eraser shapes, so like you can get a star or like a square or a circle. Then each shape goes to the red machine, the blue machine, yellow machine, or green machine to have a side colored. That makes sense. Manager notices that an uncolored side on some erasers is flawed and at the end of the process and wants to know which machine needs to be fixed, the shape machine or some of the color machines. The manager collected data on the number of flawed and unflawed erasers of each. So, in case you didn't know, flawed means there's a mistake. And unflawed just means that there is no mistake, okay? So here's the data. Work with a partner. Each of you should make one segmented bar graph. Okay, so let's figure out what percentage of these are flawed and what percentage of these are not flawed. So I think what we want to do is just look at what percentage are flawed, because if we know what percentage of those are wrong, then that could tell us, right, what percentage are not wrong. So for red, we're going to do 15 divided by 300. And if you do that as a decimal, that's 0.05, which means it's 5%. So 5% of those are messed up. The next one's going to be 17 divided by 240. And that's going to be 0.07083, which is approximately 7.083%. So there's a higher chance that the blue machine is messing it up. The next one's going to be 80 over 200. Oopsie. 80 over, 80, over 200. And that's 0.4. And as a percent, that's 40%. Jesus Christ, just get rid of the yellow machine. And then the next one, 65 divided by 260. 65 divided by 260 is equal to 0.25, which is going to be 25%. So two machines seem to be messing up. The yellow machine and the green machine, because the yellow machine is doing 40% messed up. Jesus. Are the flawed erasers associated with certain colors? Yes. Green and yellow. Ooh. Yo, this is kind of nice. I might ramble here for a bit. Based on the federal budgets for 2009, federal budget is how much money the U.S. government plans on spending for that year, okay? The table shows where some of the federal money was, keyword here, expected to go, right? The values are in billions of U.S. dollars. Ooh, this triggers me. So the United States spent $718.4 billion on national defense, aka the military, and they only spent 44.9 on education. Mind you, we have 300 million people, okay? Now Japan spent 42.8 billion on the military, but they spent more, not only on education, but more than what the US is spending. And the population of Japan is nowhere near that of the United States. And then the United Kingdom, they're spending twice as much on education than they are on the military. If this doesn't trigger you, then I don't know what does. Seriously. Anywho, why would a segmented bar graph be more useful than the table of data to see any associations between the country and where the money is spent? Well, for starters, if you have a segmented bar graph, right? Here's the US, here's Japan. They made Pokemon. Oh geez. And here's the UK. You're gonna see, right? If this is defense and this is education, you're gonna see it's gonna be like this. You can see how much more the US spends on defense than they do on education. And here they are trying to convert most public schools into charter schools so then we can give most of the money to these corporations that are just running schools. Is there an association between the country's budget and their spending in these areas? No, there is no association. There is no. You can't, just because we know how much a country spends on education, we don't know how much they're going to be spending on defense. Although I'll tell you this, the bigger the ego of the country, the more they spend on military. This number is just outrageous. The U.S., just think of it as a bully, They're all tough and show. They got all the good stuff. But in reality, They suck. In an earlier lesson, we looked at data on meditation and state of mind in athletes. Okay? Is there an association between meditation and state of mind? Do you think the more you meditate, the less calm you are? Of course. The bar graph shows the more athletes were calm than agitated amongst the group that meditated. More athletes were agitated than calm amongst the groups that did not. We can see the proportions of calm meditators and calm non-meditators from the segmented bar graph, which shows that about 66% of athletes who meditated were calm, whereas only about 27% of those who did not meditate were calm. That does not necessarily mean that meditation causes calm. Just because you meditate doesn't necessarily means it's going to make you calm, but it could be another way around that calm athletes are more inclined to meditate. But it does suggest that there is an association between meditating and calmness. So just because it makes you think that, they're related doesn't necessarily mean that one is causing over the other. In statistics, and you'll hear, if you take statistics in high school, right, if we ever go back to school, you're going to hear this correlation does not imply causation. And what this means is just because you notice a pattern between two things does not mean that's the reason why they're related. An example of this could be, no, I can't think of an example right now. Actually, yeah. So the older you are, the more money you have. This doesn't mean that the younger you are, the less money you have. I mean, actually, that kind of does make sense. You know what? Never mind. Please do the homework. Have a good